Okay, this question here, we want to determine the value of x. X is a side length here. We have an angle and we have a side. We want another side. Instantly. So ka toa. We have a side length, we have an angle, and we want the final side. We're always going to do so ka toa. Next step here, label the diagram. Label what sides of the triangle we have. So, always start, I would say, with the opposite. Opposite is always, as the name would suggest, opposite the angle. Imagine you're at the angle and you're looking away. That's the side opposite to you. Then adjacent will always be next to the angle, so that'll be down here. And the hypotenuse is always the longest side of the triangle, or you could think of it as opposite the right angle. So now we have the triangle labeled. What do we have? We have the opposite side. We want the adjacent side. If we look up at SOHCAHTOA here, we want the adjacent side. We have the opposite side. We're going to use tan. So tan of theta, the angle, is going to be O over A. That's what tan is. So that means that the tan of 20 degrees, O is 10, A is X. That means that X is equal to 10 divided by the tan of 20 degrees. Just throw that into your calculator then. So we have 10 over the tan of, I have my calculator in degrees mode, make sure, or in radians mode, should be in degrees mode. So 10 divided by the tan of 20 degrees, that will be 0.5. No units, just 27.5. That's the length of x. This question here, we want to determine the value of a. A is the angle. So again, without even thinking, we're going to be doing SOHCAHTOA. We want the angle. That's the only way we can get the angle is SOHCAHTOA. What sides do we have? Let's label the triangle again. Opposite over here. Adjacent next to the angle, and hypotenuse opposite the right angle. What do we have? We have the opposite and the hypotenuse, O and H. So we're going to be using sine. Sine of A is equal to O over H. O is 4 and H is 5. Now this is the tricky part. We have the sine of A is 4 over 5. That means that A is going to be the inverse sine of 4 over 5. Inverse sine, it's on my calculator, you click second function and you click the sine button. It's just a way you get the angle from the side length, if that makes sense. Just plug it into your calculator. Don't think about it too much. Inverse sine of 4 over 5, that's going to give me 53.13 degrees. So that's the angle. Done. This question here, they want us to determine the side length x and the angle A in this big triangle here. Let's get the angle first. So here we can imagine that we just have this triangle here. So the angle here is A, the height here is 6, and the base here will be half of 16, which is 8. So again, same as before. We have two side lengths. We want the angle. So SOHCAHTOA. Now, what sides do we have? Label the triangle. As always, label the triangle. Opposite over here, adjacent down here, hypotenuse over here. So we have the opposite and adjacent. So we're going to be using tan. So the tan of A is O over A. That means that, that we can fill in that as 6 over 8. That means that A is equal to the inverse tan of 6 over 8. So fill that into your calculator. Inverse tan of 6 over 8. 36.87 degrees. 36.87 degrees. That's the measure of the angle A. Now they also want us to get the side length x. So we'll draw the other triangle here. We have x here. We have the height was 6, and again the base was 8. This time we have two side lengths. We want the third. In this scenario now we use Pythagoras. A squared plus b squared is equal to c squared. C is always the hypotenuse, and A and B are just the other two sides. So 6 squared plus 8 squared is equal to x squared. 6 squared is 36, 8 squared is 64, is equal to x squared. So 100 is equal to x squared. That means that x, I'll draw it over here, is equal to the square root of 100, square root of 100, which is equal to 10. That's what x is, 10. The side length is 10 and the angle was 36.87 degrees. This question, we want to find the missing angle in the triangle. So we have three sides and we have an angle. Notice we don't have multiple angles. We have 0 angles. We want to find this one, but we have the sides. In this case, we're going to be using the cosine rule because we don't have any angles. So the cosine rule is going to be, we're going to have this side here is A, this side here is B, this side here is C, and this angle here is going to be capital A. So A squared is equal to B squared plus C squared minus 2BC cosine of A. That's the formula. Make sure you label the triangle properly. That's the only way you could get this wrong. Then we just fill in. So A squared is just going to be 20 squared is equal to 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of A, which we don't know A, but we'll get that at the end. Now, 20 squared is going to be 400. 9 squared is going to be 81. And 13 squared is 169, I think. Yeah. Plus 169 minus 2 times 9 times 13 minus 234 cosine of A. That's what we have. What will we do? Bring these guys over here first of all. Bring them over to the left. So we'll have 400 minus 81 minus 169. That's going to give us 150 is equal to minus 234 cosine of A. That means that the cosine of A is going to be 150 divided by minus 234. And that'll mean that A is equal to the inverse cosine of 150 over minus 234. Like that. Then just fill it into your calculator. Inverse cos of 150 over negative 234. And that's going to give you 129.9 degrees. So that's the angle. Remember, key thing here, label the triangle properly, and the angle has to be opposite the side. So like this small a will give us this big angle A. If I put A over here, it would be the angle down on the bottom right here. Final question in this section. We have a triangle ABC. We have the angle between AB and C is 20 degrees. The length of the side AB is 14, and the length of the side AC is 20. We want to find the value of BC. First thing you do here, always sketch the triangle. So just roughly guessing, I'm going to say this is A, this is B, and this is C. ABC. So the angle, that looks like a 13. That should be a B. And see, the angle always goes at the one in the middle. So it's going to be at B. So here we're going to have 20. AB is 14. AC is 20. We want to find this length here, BC. What are we going to do? If we had multiple angles, we would use the sine rule, but we don't. We only have one angle. We need this side. So we're going to use the cosine rule again. Now, what are we going to do? 20 squared is equal to 14 squared plus, I'm going to call this side length here x, plus x squared minus 2 times 14 times x times the cosine of 20. Remember, A here is down here. Sync, I guess. A is down here. We're talking about the angle opposite it, which is 20. So now we just fill in. 414 squared is 196 plus x squared minus 2 times 14 is 28. 2 times 4. Yeah, I'm just going to leave it in terms of cosine for now so I don't make a mistake. So I've got 28x times the cosine of 20. Now, bring everything over to the right. We're going to end up with a quadratic here. So we're going to have x squared minus, actually, I'm going to have to fill it in. I'm going to fill in negative 28 times the cosine of 20. That is going to be minus 26.31 x. And then 196 minus 400, when we bring over the 400, is going to be minus 204 is equal to 0. Bringing it over like that. Now, this is just a really dirty quadratic. So we're just going to fill into the minus b formula. So a is just going to be 1. B is going to be negative 26.31. And C is going to be minus 204. That means when we fill into the minus b formula, I'm not going to write it all out. Surely by now you would know the minus b formula. It's going to be minus b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 204, minus 204, all divided by 2 times a. So we're going to get x equals 32.57, or x is equal to, when we do the minus, negative 6.26. So we get two values for x. But remember, x is the distance between b and c. So we can't have a negative distance. So we can actually disregard this answer here, and x is going to be 20 or 32.57 is going to be the final answer.